When the ground starts to shake, we tend to think of buildings in pretty simple terms. They either stand or they fall. But what if there's a third option? What if a building could actually outsmart the very earthquake that's trying to bring it down? Well, today we're going to explore exactly how engineers are making that a reality. And no, this isn't science fiction. For decades, engineers have been thinking beyond just brute strength. They've been asking this exact question, designing structures that don't just resist seismic forces, but actually adapt to them. And it all starts with understanding the biggest danger of them all, a little thing called resonance. So every single building has its own natural rhythm, right? A frequency it likes to sway at. Now, if an earthquake's waves happen to hit that exact same frequency, the effect gets amplified like crazy. It is literally like pushing a kid on a swing. A few small, perfectly timed pushes can send them flying. For a building, though, that flying motion is, well, it's catastrophic. So here's the key. To save the building, you have to break the rhythm. And one of the earliest and honestly most clever ways to do that takes us all the way back to the 1970s. It's a brilliantly simple idea. What if a building had its own mechanical fuse? Now, this might look like a totally ordinary apartment building, but it's part of a huge wave of innovative construction that happened across the former Soviet Union. And hidden inside its foundation is a secret system. One designed to do one thing, change its mind in the middle of an earthquake. The secret is a technology called disengaging reserve elements, or DREs for short. These are special parts that are only installed on the ground floor, and they are designed to be the building's weak point, but in a really, really smart way. So, how does this actually work? Well, at first, the building is totally rigid. But if the shaking gets too intense, past a certain point, these DREs act like sacrificial fuses. They're literally designed to break. The second they snap, the whole structure of the building fundamentally changes. It instantly becomes way more flexible, which completely shifts its natural frequency. And just like that, the dangerous rhythm is broken. The building basically detunes itself from the earthquake. How cool is that? And the power of this idea is just staggering. The whole system is designed to cut the seismic load, the stress, on the building in half. It's not about using more concrete or more steel. It's about cleverly getting out of the earthquake's way. It's a mechanical solution that's both super simple and incredibly effective. Okay, sacrificing parts is clever, for sure. But what if a building didn't have to break to survive? What if, after it got damaged, it could actually heal itself? This is where modern material science, inspired by biology, really starts to shine. So this really shows the huge difference in thinking. The DRE system is sacrificial, right? The fuses break, and then someone has to come in and manually replace them after the quake. But the new frontier, where we're headed now, is regenerative systems that heal themselves automatically, kind of like a living thing. One of the most fascinating ways they're doing this is with self-healing polymers. So imagine you mix a special fluid, full of nanoparticles, right into the concrete. When a crack starts to form, the intense pressure right at the tip of that crack squeezes the nanoparticles, turning them back into a liquid. This liquid then flows right into the gap and hardens, sealing the damage completely from the inside out. And that's not the only way. Researchers are doing all sorts of incredible things. They're developing concrete with dormant bacteria inside that wake up when water from a crack seeps in, and they start producing limestone to fill it. Others are embedding tiny little microcapsules of resin that pop open when damage happens and release their healing goo. It's a whole new class of materials that don't just put up with damage, they actually reverse it. The goal here is pretty simple, but it's also revolutionary: to create structures that last way longer and need a lot less maintenance. And these aren't just stuck in a lab somewhere. Pilot projects in countries like the Netherlands, Japan, and Sweden are already testing this self-healing concrete in real-world roads and bridges. They're really aiming for a future with much more durable, resilient infrastructure for all of us. Okay, so we've gone from sacrificial parts to self-healing materials. What's the next logical step? Well, how about we give our buildings a nervous system? Let's talk about structures that can actually think. When you ask experts to weigh in on which new technologies are going to have the biggest impact on structural engineering, one really stands out. Yeah, nanotechnology and AI are huge, but look at this. IoT integration, the Internet of Things, is seen as having the biggest impact of all. The idea that we can connect our buildings to a network, giving them the power to sense and communicate, well, that's a total game changer. So what can a thinking building actually do? Well, a whole network of wireless sensors could act like its nervous system, constantly checking stress levels or detecting things like gas leaks. It could even automatically adjust parts of itself to dampen vibrations during a tremor. And in the absolute worst case scenario, RFID tags embedded in the walls could help rescue teams find survivors in the rubble. The building itself would become a tool for rescue. When you look at the diagrams of those original DRE systems from the 70s, right next to the concepts for modern smart materials, you can see this amazing evolution. The technology is totally different. I mean, we've gone from mechanical joints to nanomaterials. But the core idea has been the same for over 50 years. Let's create adaptive structures that can intelligently respond to what's happening around them.
So, where does this whole journey leave us? Well, it leads us to a future that isn't just about building strong things, but about building resilient things. A future where our infrastructure isn't just built, but is almost born with the ability to adapt, to heal, and maybe even to think.
The whole story of modern seismic design really boils down to this one simple, powerful idea. We're moving away from just brute force engineering and into this new era of intelligent, responsive architecture. We're not just building stronger anymore, we're building smarter. So, as our buildings start to gain the ability to heal themselves and to sense the world around them, it leaves us with one last pretty exciting question. They're becoming truly adaptive. So, what on earth should we teach them to do next?